Hello and good morning, dear students. Today we are going to start chapter number 4 of your S.Y.BSc course. Title of chapter is Interference and Diffraction. So our course will be optics. So in fourth chapter, here we are going to see two phenomena of light. First phenomena is interference, second phenomena is diffraction. Those two phenomena are related to wave nature of light. Okay, so we have to take into consideration wave nature of light, and from that ground we are going to study these two phenomena, because these two phenomena are observed for waves. So first of all, I'm sure you already studied what is mean by interference. So interference, uh, definition of interference is that interference is non-uniform distribution of energy. So you see definition of interference, it is non-uniform distribution of energy which is obtained by superposition of waves. Okay, so if we have two sources, interference is obtained by two sources of light. There must be two different waves to get interference. So if we have two different sources, and if we are superimposing waves from that two sources, then these two superimposed waves can produce interference. Okay, so you can observe interference for any type of waves, not just light wave, sound wave, pressure wave, okay, or you can say ripple waves in water. So from that we can also get phenomena of interference. Now next, see definition of interference. You already studied, that's why I told you. Interference is non-uniform distribution of energy, okay, of waves obtained by waves by superimposing two or more waves from a different sources. Here you already know there are two type of interferences. First one is constructive interference, and second one is destructive interference. So what is mean by constructive interference? For that, if we have two waves which are in phase, okay, suppose these are the two waves are in phase, and if we superimpose these two waves on one another, if you take this wave and put on this wave, or if we allowed these two waves to travel at a single time in a medium, दोन वेव्स असतील आणि एक मीडियम असेल, त्या मीडियम मधून पहिली वेव्ह गेली आणि नंतर दुसरी वेव्ह गेली, आपण काय केलं, ऍट अ टाइम दोन्ही वेव्ह पास केलं. At that time these two waves travel like this, their amplitude is enhanced, okay, this amplitude. Now you know that amplitude of this wave is this distance, okay. So if you look into intensity, so intensity is proportional to a square. So intensity of this wave is proportional to a square. Intensity of this wave, since these two waves are identical, this wave proportional to a square. Now if you add these two waves or superimpose these two waves, then we know that by adding these two waves, this wave having intensity of 2a, okay, because amplitude is a, so here this amplitude becomes 2a, this amplitude and this amplitude adds, but you know that intensity is proportional to square of amplitude, so it is proportional to 2a square, so that is proportional to 4 into a square, okay. Now initial intensity is a square, okay, this intensity is a square, so if you superimpose these two waves, you will get intensity 4 times, okay. So this resultant intensity is greater than intensity of two waves. That's why this is known as constructive interference. Okay, because intensity of resultant wave is greater than addition of intensity of two waves. If you add intensity of these two waves, it becomes 2a square plus a square. But here we will get 4a square. Okay. Now next one is destructive interference. In destructive interference, we have wave which is traveling like this, and another wave which is out of phase from this wave. Out of phase means what? This wave is moving like this. Now amplitude is A, amplitude is A. These two waves are out of phase with each other. If you allow to interfere these two waves, then we will get destructive interference, and amplitude of resultant is 0. Why? Because A minus A becomes 0. So here amplitude of resultant wave is less than individual amplitude addition. That's why this is known as destructive interference. Now you know condition for constructive and destructive interference. What is the condition for constructive interference? If two waves are in integral multiple of wavelength, then we will get constructive interference. What is the meaning of integral multiple of wavelength? So for that, you know that wavelength is the distance between two maxima or two minima successive. Okay. So if this wave is integral multiple of this wave, means m lambda. If m is equal to 0, we will have this situation. If m is equal to 1, then this means m into lambda. This wave came in phase with this wave. We can translate this wave by one wavelength distance. So we can take this wave and move like this. Again we will have another wave which is in constructive interference with this wave. Okay, try to understand this. See why this condition came for constructive interference. If we have this wave and another wave having wavelength which is integral multiple of first wave, then these two waves came in such a way that these two waves are in phase with each other. Okay, suppose m is equal to 0, then we can draw this figure like this. If m is equal to 1, means phase difference between these two is lambda. Okay, this is the phase. Okay, initial phase. This is 0, this is 0. And phase difference is lambda. It means again these two waves came in phase. So try to understand difference between phase difference and path difference. Phase difference means what? Here on the y-axis and on x-axis, suppose this wave can be written as sine omega t, y is equal to, then here on the y-axis we have y, and on x-axis we have omega t. Okay, so initial phase difference means what? At t equal to 0, this y position is this. So y 0, y 0. So phase difference depend on this factor. Okay, and path difference. Path difference is distance between, since it is path, so it is distance. It is difference between path traveled by these two light waves. Okay. Now, if phase difference is 0, means path difference is 0. Okay. If phase difference is pi means 180 degree. Okay. Then path difference is lambda by 2. If phase difference is 2 pi, then path the difference is lambda. Why that relation came? Because we know that for a single wave, okay, this is 0, this is 360 degree or 2 pi. Single wave complete in a 2 pi distance, and this distance is lambda. So we can say path difference of lambda and phase difference of 2 pi. Okay. So lambda by 2 means this distance. Okay, and that becomes 180 degree, which is pi. Okay, so 0 means 0, 360 phase difference means 360 phase difference or 2 pi phase difference means lambda. Path difference and 180-degree phase difference means lambda by 2 path difference. Okay. Now next, constructive and destructive interference. If you look into interference pattern, we will have alternate series of constructive and destructive interference. So interference pattern look like this. Here this is phase difference. Here we have intensity, which is 4a square cos square delta, where delta is the phase difference, okay, between two waves. If you plot this and if you put this delta, okay, which is phase difference between two, and we will get interference pattern like this. Okay. Now here we have alternate maxima and minima. This is constructive interference, so we will have maxima. This is destructive interference, minima. Again maxima, minima, maxima, minima, maxima, minima. Okay. So in the interference pattern, you will see fringes. So here you will see bright fringe. Okay. Here you will see dark fringe. Here you will see bright fringe. Here you will see dark, bright, dark, bright, dark, bright, dark. Okay. So in this way you will see interference pattern. Now in this interference pattern, alternate dark fringe means constructive interference. Sorry, dark means destructive interference. Bright means constructive interference. All these we can say have same intensity. Okay. See, this is the difference between interference and diffraction. In diffraction, we have central maxima, first order minima. Okay, but in interference pattern, we all the fringes are maxima. Okay, this is maxima, maxima, maxima means what? All this is having same intensity. Okay, with this, how to get interference pattern, we will see in next section. So interference can be obtained by two methods or two ways. First one is division of wavefronts, and second one is division of amplitude. Okay, so here amplitude must be there. Now what is meant by division of wavefronts and division of amplitude? Suppose we have single source and we have to get interference from that single source. Then we have to split that light ray into two or more light rays to get interference, because interference must be obtained by at least two waves. Okay, so in this light ray we have to divide that light ray, okay, into two different rays or three or four rays, and allowed them to come at a single point. When they came at single point, then we will get interference pattern. Okay, so that division, if we divide wavefronts, then that phenomena is known as division of wavefronts. If we divide amplitude, then such phenomena is known as division of amplitudes. Okay, now definition of division of wavefront. How can you define division of wavefront? Suppose we get interference by dividing wavefront of a source, optical source or wavefront of light, and allowed them to superimpose on one another, then such interference pattern is known as division of wavefronts. So in this case, source of light must be narrow slit. Okay, narrow means what? The size of that slit should be very less than wavelength of light. Okay, so here this phenomena obtained in double slit experiment, we can take this division of wavefront advantage. In double slit, biprism, voids, single mirror. So in this experiment we can get interference by division of wavefronts. Now second, division of amplitude. So division of amplitude means what? Suppose we have a wave, light ray wave, and if we allowed the intensity or amplitude of that wave to divide in one and more parts, and then allowed them to interfere or superimpose on one another, then such phenomena is known as, such interference is known as division of amplitude. So here, to get division of amplitude, source must be extended slit source. Okay, so examples are parallel sided and wedge shaped thin films. So we are going to study these two parts in detail. Another is Newton's rings, Michelson interferometer. So interference obtained by these experiments is division of amplitude. Next one, thin film. So we are going to study thin film. First of all, definition of thin film. A thin film which is having thickness in the range, any material having thickness in the range 0.5 micrometer to 10 micrometer. Okay, such film is known as thin film. If this thickness is greater than 10 micrometer, then we can say it is thick film. That is not thin film. So thin film can be obtained where you must have seen soap bubbles. Okay, in that soap bubble, thickness of that soap bubble is in this range. So if you look on soap bubble, you can see fringes. So that is interference. Okay. Then another example of thin film. There is some coating on some glass material. So if that layer thickness of that coating is this in this range, then we can say interference. Or you can say तुम्ही मोराच्या याच्यावर मोराचा जो पिसार असतो, ठीक आहे, त्याच्यावर जो कलर दिसतो आपल्याला, तो कलर कशामुळे दिसतो? दॅट इज ड्यू टू इंटरफरन्स. ओके, कारण की त्या मोराचं जर पीस पाहिलं तर त्या मोराच्या पिसावर लेयर असतो थिन फिल्मचा. ओके, जे बायोमॉलिक्युल्स असतात त्यांचा लेयर असतो. त्या लेयर पासून जे आपल्याला रिफ्लेक्ट होऊन जो दिसतं, ठीक आहे, वेगवेगळे कलर, तर ते दॅट इज ड्यू टू थिन फिल्म. त्याच्यानंतर if we pour oil on surface of water, वॉटरच्या सरफेसवर ऑइल टाकलं आपण आणि साइडने पाहिलं तर आपल्याला कलर पण दिसतात त्याचे कधी कधी, ठीक आहे. सो दॅट ऑल्सो फॉर्म अ थिन लेयर. सो देर आर मेनी एक्झाम्पल्स ऑफ थिन फिल्म्स. सो थिन फिल्म मे बी ऑफ एअर, ओके, or glass or any material you can take and you can make thin film of that material. Next, we are going to study next point, phase change on reflection, which is also known as Stokes treatment. So before that, here I have drawn thin film. Okay, so this is thin film having any material which is having refractive index mu. Refractive index is very important factor for studying interference and diffraction of any material. So suppose this material having refractive index mu, and suppose light having intensity 100% is incident at this point. So at this point it is partly reflected and partly refracted. Okay, so this is reflected and this is refracted. So out of 100%, only 4% of light is reflected. So this is intensity. Only 4% intensity of light is reflected, and out of refracted in this thin film, at this point it is again partly refracted and partly reflected. So this light ray is known as transmitted light ray because this is incident and this came out of this thin film. That's why this is known as transmitted. So 92% intensity of light is transmitted. See, 92 and 4%. There is very large difference. Now here again at this point the light ray again partly reflected and partly refracted. So intensity is 3.65%. So this is shown by number 2. So again partly here partly refracted and partly reflected. At this point again partly reflected, partly reflected. Now for this third wave light ray intensity is 0.005% of initial intensity. So this is almost 0. Okay. Now if you get interference pattern, we only show only 2 light rays. Why? Because intensity of this is 4 and this is 3.65. If you allowed them to construct by putting lens over here, okay, at this point, then here we will get interference pattern. Okay, so at this point where we are getting interference pattern, so these 2 light rays having intensity comparable, that's why we can get here interference. If you take this light ray whose intensity is very less, so that is almost 0. Here also these 2 light rays having intensity comparable, that's why we can pick these 2 light rays. So if you allowed these 2 light rays to get interference pattern, this is known as interference by reflection and this is known as interference by transmission, because these 2 light rays are transmitted. Okay. Now we are going to study this phenomenon. Stokes treatment. Now this is related with phase change on reflection. Okay. So for this, see this figure. Suppose this is the wall we are talking about, and if wave came in a rarer medium and reflect from denser medium back. Since this is denser medium, okay, the wave will bounce like this and go like this. Means incident wave and this is reflected wave. These 2 waves have out of phase. These 2 waves are out of phase. So if you look into path difference of these 2 waves, incident and reflected wave, then path difference is lambda by 2 and phase difference is pi. Now if light wave came from denser medium and reflect from rarer medium. See, if light came from denser medium to rarer medium. So at this interference, at this interface, if light wave is reflected, then it is reflected in the same way, not like this. Why? Because rarer medium will oscillate like this. Okay, but denser medium is strong compared to rarer medium, so it will not bounce back. So light wave came, and if you look into path difference, which is 0, and phase difference is 0. Okay, so remember this, लक्षात ठेवायचं. जर लाईट रे आला आणि रिफ्लेक्ट झाला कुठून, रेअरर मीडियम पासून डेन्सर मीडियम असेल, इकडून डेन्सर मीडियम पासून रिफ्लेक्ट झाला, तर डेन्सर मीडियम पासून रिफ्लेक्ट झाल्याच्या नंतर हा जो रिफ्लेक्टेड असेल, ठीक आहे, त्याचा पाथ डिफरन्स किती असणार आहे, लॅम्बडा बाय 2 किंवा फेज डिफरन्स काय असणार आहे, पाय, कारण की रिफ्लेक्टेड वेव्ह काय असणार आहे, याच्या अपोजिट येणार आहे, ठीक आहे, रिफ्लेक्टिव्ह. इकडे तसं नसणार आहे. जर लाईट डेन्सर मीडियम मधून आली आणि रेअरर पासून रिफ्लेक्ट झाली, ठीक आहे, इकडून इकडे, तर त्या केस मध्ये काय होईल की इकडून इकडे रिफ्लेक्ट झाल्याच्या नंतर तिथं पाथ डिफरन्स आणि फेज डिफरन्स नसणार आहे, सेम आहे, त्याच्यामध्ये काय होईल, रिफ्लेक्ट होईल. आपल्याला पुढच्या सेक्शनला यूज करायचं. ओके, विथ दिस वी stop our lecture over here. Okay, in next lecture we will see next point.